Okay, we're going to calculate the future value of annuities. And annuities are just investment vehicles where you're making periodic investments or you're taking money out periodically. So an example of an annuity would be investing $100 a month for the next 10 years at a given rate or something like that. Okay, so here's the formula for an ordinary annuity. And an ordinary annuity is when you make or receive a payment at the end of each period. So like if you were doing monthly payments into an account, an ordinary annuity is when you make those payments at the end of each month. An annuity due is simply when you make those same payments at the beginning of each month. And there's a slightly different formula depending on when you make those payments, at the beginning of the period versus the end. And so we're going to start with ordinary annuities. Okay, for number one, you're told that this is an ordinary annuity, but you don't need to be told that because the $1,000 is being invested at the end of each year rather than at the beginning. That implies that it's an ordinary annuity. Okay, so if we wanted to calculate our future value, it would be our payment size of $1,000 times 1 plus our rate of 9% over n, which is annually, to the 1 times 25 years, there's 25 years, minus 1, over 0.09 over 1. And of course, you don't have to divide by 1. I'm just showing it there. So I got $84,700.90 after rounding off to the nearest penny. Okay, now we're talking about 25 payments, 25 years, one payment each year at $1,000 per payment. So we're talking about a total contribution of $25,000. But we end up with $84,000. So we subtract to get the amount of interest, which comes out to $59,700.90. So this problem, we earned $59,700.90 off of a total contribution of $25,000. Okay, again, in example 2, they're telling us it's an ordinary annuity, so we know to use this formula. But even if they didn't tell us explicitly, we have to know that because the payments are being put into the account at the end of each month. All right, so the first thing we're going to do is calculate the future value. And that's going to be the size of the payment, the $350 in this case, times 1 plus the rate, 14%, divided by the number of compounding periods per year, which is 12, to the 12 times number of years, there's 14 years, minus 1 over our rate, which is 14% divided by 12. And this is going to come out to $180,577.17. Okay, now in order to calculate the interest, we are making a total of, well, I'm not even sure, but there's 14 years worth of payments and 12 payments per year because we're making them monthly. And the payments are $350 each. So we are making a total of $58,800 in total payments into this account. And it becomes worth $180,000. So we get, let's see, what does this come out to? 121,000. Oh, I made a mistake here. What did I do? Let me pause. No, that was right. $121,777.17 in interest. Okay? And that's off of a total contribution of $58,000. So that's pretty good. again, not to beat this into the ground too hard, but we know this problem tells us it's an ordinary annuity. If you were in a test, it may not explicitly say that. So you have to understand that because these payments are made at the end of each period, this is an ordinary annuity. Okay, so we're going to calculate the future value first. That's going to be the payment size, the $1,350, times 1 plus our rate of 11%, divided by compounding quarterly, that's 4 times per year, 4 times, this is 18 years, minus 1, over 0.11 over 4. Okay, this will come out to, looks like 297,081 point, after rounding off to the nearest penny, to 84. Okay, now to calculate the amount of interest, well, we're making 4 payments per year for 18 years, so we're making that many payments. Each payment is $1,350. So that comes out to $97,200 of payments into this account. That gives us $199,881.84. And that's what we put here. The total interest is $199,881.84. Oh, the dollar sign's already there for us. Okay. All right, example 4, we're making payments at the end of each day. So this is an ordinary annuity. To calculate the future value, we're going to say that this is equal to the size of the payment, $12 in this case. They're saving some money every day. 1 plus a rate, which is 13%, over 365, since we're compounding daily. And this is 365 times the number of years, 9 years, minus 1, all over 0.13 over 365. Let's see what this comes out to. This comes out to 74,841.45 after rounding off to the nearest penny. All right, now we are making a total of 365 payments for 9 years. So a total of that many payments at $12 a piece. That comes out to $39,420. So this is going to be a total of $35,421.45 in interest. All right, this is getting redundant, but number 5, we are making these payments at the end. So this is an ordinary annuity, so we'll use this formula. And our future value is going to be $4,500. That's the size of the payment, times 1 plus our rate, 7%, divided by, this is semi-annually, so that's twice a year. 2 times, this is for 14 years, minus 1. Every 6 months is just another way of also saying semi-annually. Okay, and this is over 0.07 divided by 2, and this is going to come out to $208,000, $307.82. Now, we are making 2 payments per year for 14 years, and we're making $4,500 payments. So this is going to be $126,000 worth of payments. And that means our total interest is going to be, I'll just write it up here, $82,307.82 in interest. All right. Okay, this problem tells you that it's going to be an annuity due, but it doesn't have to explicitly state that. The fact that we're making these payments at the beginning of each period tells us that. Okay, so we are going to calculate the future value using this formula this time. So our future value is going to be equal to $1,000 payments times 1 plus our rate, which is 10%, over our N, which is compounded monthly, and this is for 15 years. And we're going to go over. Now, everything up to this was exactly the same as an ordinary annuity. But when you have an annuity due, you have this extra factor we're going to multiply by this amount right here. Okay? So it's going to increase the amount a little by a small factor because we're earning our interest sooner and our compounding sooner. Okay, so this is going to be 0.1 over 12. This should come out to, make sure you're doing this on your calculator so that you're confident that you can do this on your own. But this should come out to $417,924.27. Okay, so in order to calculate the interest, we are going to make payments monthly, so 12 payments a year for 15 years. Our payment size is $1,000. So this is going to come out to $180,000. So we are going to make I should do this in my head, but I don't want to think. This should come out to $237,000, 924.27 in interest. Okay, again, we're told that this is an annuity due, but we don't have to be told that. We can infer that, and we know that because this payment of $1,250 is being made at the beginning of each period, in this case month. So our future value is going to be equal to, and we'll use this because it's an annuity due, $1,250 times 1 plus our rate, 0.12, and this is monthly, and this is 12 times 7 years, times this extra factor right there. Okay, let's see what this comes out to. Make sure you can do this on your own calculator, but I got $164,973.75. Okay, now we are making payments every month, 12 times a year for 7 years. So there's that many payments. And each payment is $1,250. So this comes out to total payments of $105,000. So to calculate the interest, we get 55,000. I guess I'll just write it up here. 55,000. Not 55,000, $59,973.75. All right, and that's it. That's the worksheet.